What if I told you a single machine once demolished 13 buildings in 90 minutes, and the police couldn't stop it? Or that the world's biggest bulldozer never once moved a single grain of dirt? Or that the military built a bulldozer so armored it can literally deflect rocket-propelled grenades? These aren't science fiction, these are real machines, and today we're counting down the 10 strangest bulldozers ever built. Number 10. The Caterpillar D9 Doobie. Kicking off our list is a bulldozer that Guinness World Records officially recognized in 2014 as the most armored bulldozer in the world. Meet the IDF Caterpillar D9, nicknamed Doobi, which is Hebrew for teddy bear. Don't let that name fool you. There is absolutely nothing cuddly about this thing. The facts? Caterpillar introduced the D9 bulldozer back in 1954. It's a powerful machine on its own. A 474 horsepower track tractor that weighs around 49 tons in its standard form. But Israel's defense forces took that standard machine and completely transformed it into something that belongs on a battlefield, not a construction site. Starting in the 1980s, the Israel Defense Forces began modifying the D9 with armor kits developed by Israeli Military Industries and Israel Aerospace Industries. By the time they were done, the bulldozer weighed up to 62 tons, 13 additional tons of steel armor protecting every critical system, including an armored cockpit with bulletproof glass windows. The cabin protects its crew of 2, an operator and a commander, from small arms fire, artillery shell splinters, and even IEDs. In 2005, the IDF added something called slat armor, a cage-like structure bolted around the outside of the machine. This slat armor is specifically designed to cause rocket-propelled grenades to detonate prematurely before they can penetrate the machine. The modification reportedly saved multiple lives. In 2018, the IDF went even further and unveiled the Panda, a remote-controlled version of the D9T that can be operated from a safe distance, keeping soldiers entirely out of harm's way. The Panda entered regular service by 2020. In 2019, defense company Elbit Systems won a contract to install the Iron Fist active protection system on D9 bulldozers, technology designed to intercept and destroy incoming anti-tank missiles mid-flight before they reach the machine. The D9 has been used in combat operations since the 1956 Sinai War and has served through every major Israeli conflict since. It can be equipped with machine guns, grenade launchers, and smoke projectors. It's been used to clear minefields, detonate IEDs, build fortifications, rescue damaged armored vehicles, and controversially demolish structures in combat zones. Number 9. The Kildozer. On June 4, 2004, a 52-year-old welder and muffler shop owner named Marvin Heemeyer climbed into the cockpit of a machine he had spent over a year secretly building in his shop in Granby, Colorado. He sealed the hatch behind him, and then he drove through the town. The fact? Heemeyer started with a Komatsu D575A bulldozer, a heavy, commercially available machine. Over the course of roughly 18 months, working in secret, he encased the entire bulldozer in steel plate and concrete. The result was an improvised armored vehicle unlike anything law enforcement had ever encountered. When finished, the machine weighed approximately 85 tons. Inside the cockpit, Heemeyer installed 2 monitors connected to cameras mounted on the exterior, allowing him to see where he was going, even though the armor completely blocked his direct view outside. He also included an air conditioner and fans to keep the sealed cabin livable. 3 gun ports were built into the walls, and he armed himself with a .50 caliber rifle, a .308 semi-automatic rifle, and a .22 long rifle. According to authorities, once he sealed himself inside, it would have been impossible for him to exit, a detail that underscored the finality of what he had planned. The bulldozer moved at approximately 5 miles per hour and systematically demolished 13 buildings over the course of roughly 90 minutes. Among the targets, Granby Town Hall, the office of a former mayor, a local bank, a newspaper building, and other businesses that Heemeyer believed had wronged him in long-running zoning and property disputes. Police attempted to stop the machine but found themselves essentially helpless. One undersheriff rode on top of the vehicle and dropped a stun grenade down the exhaust pipe. It had no effect. Bullets bounced off the plating. The rampage caused more than $7 million in property damage. Finally, the machine became stuck in the basement of a hardware store it was in the process of destroying. Heemeyer then took his own life. No one else was killed or injured during the entire 90-minute rampage. The machine, which the media quickly dubbed Kildozer, was later cut into pieces and distributed across multiple scrapyards to prevent anyone from taking souvenirs. Today, Liebherr has developed a complicated internet legacy, with some viewing him as a folk hero, a characterization strongly disputed by those who witnessed the destruction firsthand. Number 8. The ACCO Super Bulldozer. The ACCO Super Bulldozer holds an extraordinary distinction. It is officially the largest bulldozer ever manufactured by weight. It weighs 183 metric tons, the equivalent of roughly 45 adult African elephants. It is 12 meters long, about 40 feet. Its blade stretches 7 meters wide over 23 feet. It stands 6.5 meters tall, and it has never moved a single cubic meter of earth for its intended purpose. The facts: in the early 1980s, the Italian heavy machinery company ACCO, run by a man named Umberto ACCO, received a contract to build a massive bulldozer for land development work in Libya under Muammar Gaddafi's government. The project was extraordinarily ambitious. Engineers designed a machine powered by 2 Caterpillar engines, each producing 675 horsepower, placed horizontally opposed inside the chassis. Combined output, 1,350 horsepower. To handle the extreme torque, the machine was built with 2 final drives, upper and lower, for maximum pulling power. Construction was completed, but the machine never shipped. The United Nations imposed trade embargoes on Libya following Gaddafi's government's involvement in international terrorism, and the bulldozer was stranded in Italy. It sat. It continued to sit. Decades passed. The ACCO family, who had commissioned the machine, eventually passed away. As of 2012, reports confirmed the bulldozer was being stored by an Italian gardening company near the town of Portogruaro in northeastern Italy. To this day, the ACCO Super Bulldozer holds the record for the largest bulldozer ever manufactured by operating weight. However, because it never actually worked commercially, the title of largest operational bulldozer in the world belongs to a different machine entirely, which we'll get to shortly. Think about that for a moment. The single biggest bulldozer in history, built at enormous expense, a true monument to engineering ambition, and it has spent its entire existence sitting in storage. A machine designed to reshape the earth, and it has never touched it. Number 7. The Komatsu D575A-3 Super Dozer. If the ACCO is the biggest bulldozer ever built, the Komatsu D575A-3 is the biggest bulldozer that actually does its job. And its job, it turns out, is almost incomprehensibly massive. The facts: the Komatsu D575A-3 Super Dozer. The SD literally stands for Super Dozer, has an operating weight of 152,600 kilograms. That's 152,006 metric tons, or roughly 336,400 pounds. It is powered by a Komatsu SSA-16 V160 engine producing 1,050 horsepower at 1,800 RPM. The machine is 11.72 meters long, 7.4 meters wide, and 4.88 meters tall. Its blade capacity, the amount of material it can push in a single pass, is approximately 69 cubic meters. To put that in perspective, a standard concrete mixer truck holds around 8 cubic meters. This machine can push the equivalent of more than 8 concrete mixer trucks worth of material in a single swipe. Because of its extraordinary size, the D575A-3 cannot be transported intact on public roads. Moving it to a new location requires completely disassembling the machine and loading it onto up to 8 separate tractor-trailer loads. Then it has to be fully reassembled at the new site. Komatsu engineers addressed a unique engineering challenge when building this machine. At this size and power level, the vibration from the engine is so extreme that they developed special rubber cushion mounts to connect the engine to the main frame, isolating the vibration and protecting the structure. The D575A-3 is primarily used in large-scale surface mining operations, particularly iron ore mining in Australia and coal mining in North America, where the economics of moving enormous volumes of material per hour justify the machine's extraordinary size and operating cost. Number 6. The Firefighting Bulldozer. Most people think of bulldozers as construction machines, but one of the most critical and dangerous roles bulldozers play around the world is fighting wildfires. And the machines purpose-built for this role are genuinely unlike anything else in the bulldozer world. The facts: wildfire bulldozers are heavily modified standard machines, most commonly Caterpillar D6, D7, and D8 series dozers that have been specifically equipped to operate in active fire environments. Their primary job is cutting fire lines or fire breaks, strips of cleared, bare earth that remove vegetation and combustible material from a wildfire's path, essentially starving the fire of fuel. The modifications for wildfire service are extensive. These machines are fitted with enclosed, climate-controlled cabs with multi-stage filtration systems to prevent smoke inhalation. Screens and guards protect radiators, engine compartments, and undercarriage components from burning debris. Specialized blade configurations allow operators to quickly strip ground cover and create breaks in terrain that is often steep, rocky, and uneven. One of the most impressive documented uses of armored bulldozers in firefighting occurred in Israel in 2010, when the Mount Carmel forest fire, the deadliest in Israeli history, broke out near Haifa. IDF armored D9 bulldozers, the same machines from our earlier entry, were deployed into the heart of the blaze to open routes for firefighting vehicles and create earthen barriers to prevent the fire from spreading. These machines operated in conditions that would have been impossible for any unarmored vehicle. In the American West, bulldozer operators who fight wildfires are considered among the most skilled and highest-risk operators in the field. Working on steep, burning terrain with limited visibility, under time pressure, they have to make split-second decisions about where to cut lines and when to retreat. The bulldozer's ability to work ground that no human crew could safely access on foot makes it an irreplaceable tool in large wildfire suppression. Number 5. Komatsu's autonomous mining dozers. The concept of a self-driving car gets a lot of attention. But autonomous heavy equipment machines weighing hundreds of tons, operating in active mines with zero human operators on board, has been a commercial reality for much longer than most people realize. The fact: Komatsu launched the world's first commercially deployed autonomous haulage system, known as Frontrunner, in January 2008 at Codelco's Gabriela Mistral copper mine in Chile. This was not a prototype or a demonstration. It was a fully operational, revenue-generating system at a real mining site. As of February 2024, Komatsu's autonomous systems had been deployed across 23 mine sites in 5 countries, with over 700 autonomous trucks in operation. These systems had collectively moved more than 7.5 billion metric tons of material, all without a human operator in the cab. 0 safety incidents have been attributed to the autonomous system since its first deployment. The technology works through a combination of high-precision GPS, vehicle controllers, obstacle detection systems, wireless network communication, and a supervisory software system called Dispatch that manages routing and fleet coordination. The system can manage dozens of autonomous vehicles simultaneously while also safely integrating with manned vehicles operating on the same site. While Komatsu's autonomous systems are primarily focused on haul trucks, the company's broader autonomous mining technology is being extended across multiple machine types. In 2023, Komatsu and Toyota announced a joint project to develop autonomous light vehicles that would operate alongside the autonomous haul trucks on mine sites, using the same Frontrunner guidance system. The practical implications are significant. Autonomous machines don't need shift changes, don't get fatigued, and can operate around the clock. According to data published by Rio Tinto, autonomous trucks in their fleet operated approximately 700 hours more than conventional trucks in 2017 alone, with 15% lower load and haul unit costs. Number 4. High-drive bulldozers. Most people look at a bulldozer and see the big blade at the front. But one of the most significant innovations in bulldozer engineering over the past half-century is something most casual observers barely notice: where the drive sprocket, the main driving wheel, is positioned on the machine. And moving that sprocket changed everything. The facts: traditional bulldozers used a ground-level drive system, where the drive sprocket sat at the back of the track at ground level. In 1977, Caterpillar introduced the elevated drive sprocket, a design where the main drive wheel is raised up above the ground at the rear of the machine. The Caterpillar D10 was the first production bulldozer to use this design, and it was genuinely revolutionary. Here's why. In a traditional low-drive system, the bottom of the track, the part in contact with the ground, is under constant load from the machine's weight. The final drives and associated components sit close to the ground and are constantly exposed to rocks, mud, abrasion, and impact. In a high-drive system, the elevated sprocket lifts the critical drivetrain components away from the ground. The track wraps in a triangular shape, up over the elevated sprocket at the rear, then forward along the ground to the idler at the front. This geometry means the final drives, the most expensive components to repair or replace, are no longer sitting on the ground taking punishment. Ground clearance increases, debris interference decreases, component life improves dramatically. The high-drive design also changed the way shock loads are transmitted through the machine. When the track hits a rock or obstacle, in a high-drive configuration, the energy travels through a different path, reducing the stress on critical drivetrain components. The design has since become standard across the industry's largest dozers, adopted by manufacturers worldwide. Today, essentially every ultra-class mining dozer in the world uses some variation of the elevated drive sprocket concept. What seems like a subtle geometric change fundamentally reshaped the reliability and operating cost economics of the world's biggest machines. Number 3. Nuclear site bulldozers. Operating heavy equipment in a radioactive environment presents challenges that go far beyond anything standard machine design anticipates. Radiation damages electronics. It degrades rubber seals and lubricants. It creates serious danger for any human operator. The solution? Build a bulldozer that doesn't need a human inside. The facts. The most documented large-scale use of remote-controlled and radiation-hardened bulldozers occurred in the aftermath of the Chernobyl nuclear disaster in April 1986, in what was then the Soviet Union, now Ukraine. The explosion at reactor number 4 of the Chernobyl nuclear power plant scattered radioactive debris across the site and onto the reactor roof. Clearing that debris was essential to preventing further nuclear contamination, but radiation levels in some areas were so high that human exposure, even briefly, could be lethal. Initial efforts to use remote-controlled robots brought in from West Germany and Japan mostly failed. The intense radiation levels scrambled their electronics and disabled them within minutes of operation. The Soviets were then forced to use human liquidators, workers who went onto the roof in shifts of only 40 to 90 seconds each to shovel debris before rotating out. Hundreds of thousands of people participated in the Chernobyl cleanup. Bulldozers were deployed extensively at Chernobyl for tasks including pushing contaminated soil and debris into burial mounds, constructing the earthen containment structures around the site, and clearing access routes. Specialized shielding was added to protect operators in areas where radiation levels allowed human presence with protection, while true remote operation was used in the highest radiation zones. Following the Fukushima Daiichi nuclear disaster in Japan in 2011, the lesson from Chernobyl about robotic and remote equipment was applied more systematically. Japanese and international teams deployed remote-controlled construction equipment extensively in areas of the site too contaminated for human workers. This included remote-controlled bulldozers used to clear debris and grade terrain around the damaged reactor buildings. Today, the nuclear industry maintains specially configured, remote-controlled, and radiation-hardened construction equipment as part of emergency response planning at nuclear sites worldwide. These machines represent one of the most extreme specialized variants of standard construction equipment. Number 2. The Liebherr PR 7760s. Most bulldozers work the same fundamental way. A diesel engine drives a torque converter, which feeds power through a transmission and final drives to the tracks. It's a system that has worked for decades. But German engineering company Liebherr built one of the world's largest bulldozers around a completely different principle. And the result is a machine that looks and behaves unlike almost anything else in its class. The facts. The Liebherr PR 776 Electronic is one of the largest crawler dozers in the world, weighing approximately 70 metric tons with an engine producing 598 kilowatts, 768 horsepower, from a Liebherr D9 512A-3 V12 diesel engine. Those specs alone are impressive, but what makes this machine genuinely strange is how it transfers that power to the tracks. The PR-776 uses a fully hydrostatic drive system rather than a mechanical transmission and torque converter. The engine drives hydraulic pumps that power hydraulic motors at the tracks. This system allows the engine to run at a constant RPM regardless of the machine's travel speed, a fundamental difference from conventional dozer drive systems. Why does that matter? Constant engine RPM means the engine is always operating in its optimal efficiency range. The hydrostatic system allows infinitely variable speed control and makes steering completely different from a conventional dozer. Each track can be independently controlled with precision, allowing movements that mechanical steering systems struggle to replicate. The PR-776 also uses a rigid track frame with bogie suspension, replacing the high drive design used by most competitors, and its cab is positioned to give the operator unusually clear sight lines to the blade corners, which is critical for precision work. According to the 2026 rankings from Lectura, a leading heavy equipment specification database, the Liebherr PR-776 ranks among the top 10 largest bulldozers in the world. It represents a fundamentally different engineering philosophy from the machines built by Caterpillar and Komatsu, proving that even in a mature industry, there's more than one way to build a giant. Number 1. The Chetra T-40. Our number 1 pick isn't the most famous bulldozer on this list. You probably haven't heard of it. But when you learn what this machine is built to do and where it does it, it earns the top spot by pure, brutal logic. Welcome to the Chetra T-40, the most powerful serial production bulldozer ever built in Russia, specifically engineered to work in one of the most hostile environments on Earth. The facts: the Chetra T-40 is manufactured by the Chelyabinsk tractor plant, one of Russia's oldest and most important heavy machinery manufacturers, which has been building tracked vehicles since the 90s. The T-40 is the company's flagship product, a 118 metric ton bulldozer producing 820 horsepower, purpose-built for use in the gold and coal mining industries of Siberia and the Russian Far East. To understand why this machine is extraordinary, you need to understand what Siberian mining conditions actually mean. We're talking about environments where winter temperatures regularly drop to -50 degrees Celsius, that's -58 Fahrenheit. At those temperatures, standard diesel fuel gels and becomes unusable. Hydraulic fluids solidify. Steel becomes brittle and can crack under impact. Rubber seals fail. Standard electronic systems malfunction. The Chetra T-40 was engineered from the ground up for these conditions. Its hydraulic systems use specially formulated Arctic-grade fluids. Its electrical systems and sensors are cold-rated to function at extreme low temperatures. Its engine and fuel systems are designed to operate and start in conditions that would disable standard equipment. Its structural components are made from steel specifically chosen for their cold weather toughness, the ability to absorb impacts without becoming brittle or cracking in extreme cold. The machine operates in permafrost, ground that is permanently frozen year-round. Mining in permafrost presents unique challenges. As machines work the ground, they can destabilize the frozen layers beneath them, creating unpredictable terrain. The T-40's weight distribution and track design are optimized for permafrost stability. The Chetra T-40 represents something genuinely extreme. It is not just big, not just powerful, but precisely adapted to an operating environment that would destroy most other machines within hours. While the rest of the world's bulldozers are built for general-purpose mining and construction, the T-40 exists for one specific mission in one of the most inhospitable places on the planet, and it does that mission reliably. Which one of these blew your mind the most? Drop it in the comments below. If you want more content about the world's most extreme engineering and the machines that make the impossible happen, hit subscribe and turn on notifications. We put out new videos every week. Thanks for watching. We'll see you in the next one.